Alright, in this example we're going to look at how to solve a trig equation using a calculator on the interval from 0 to 2 pi. Here we have sine theta equals negative 0.45. The first thing we're going to do is we're going to take the sine to the other side, and that'll give us theta equals to the inverse sine of negative 0.45. And so now what we can do is we can go grab our calculator and calculate the inverse sine of negative 0.45. Alright, so here we go. We got our Casio, and we want to do the inverse sine of negative 0.45. And that's going to give us a value of negative 0.47 if we round to the nearest two places, nearest hundredth. And notice that that is in radian mode. So that's going to be a radian angle, negative 0.47 rounded. Negative 0.47 rounded. Now, if you notice, that angle in radians is definitely not on the interval from 0 to 2 pi. That is a negative angle. And so what we're going to have to do is we're going to have to find the correct angles on the interval from 0 to 2 pi. So for that, we're going to go to the unit circle. And we're going to notice that, first of all, the angle is negative, which means it's going clockwise. If we pull up our note here, we've got that the angle is going to be negative going clockwise, and the angle is negative 0.47. So what that means is, it means that this angle is 0.47 radians away from 0 degrees. So there's going to be an equivalent angle in the third quadrant that's going to be 0.47 radians past pi. So one of my answers is going to be pi plus 0.47. And the other angle, let's see here, let's draw these out. So from here to here, the angle that's in the third quadrant is going to be pi plus 0.47. And then the fourth quadrant angle, if I go from here all the way around to here, that's going to be actually 2 pi, because if I keep going, I get a full circle, 2 pi minus 0.47. And I know that I need a third and a fourth quadrant angle, because if we go back and look at the original problem, we see that sine is negative. And remember, sine is y, so we want to know where is y negative. And y is negative in the third and the fourth quadrant. So our two angles are going to be pi plus 0.47. And the other answer is going to be 2 pi minus 0.47. And so those angles are going to be, if I go to my calculator, that's going to be pi plus 0.47, which is 3.61. And the other angle is going to be 2 pi minus 0.47, which is going to be 5.81. And so those are going to be my two radian angles on the interval from 0 to 2 pi that satisfy this equation. And now, as a bonus, what I think I'd like to do is actually check these using DESMOS. So we know that our equation that we're looking at is y equals sine theta. And remember that we're looking on the interval from 0 to 2 pi, so we're going to restrict the domain to be from 0 to 2 pi. We also know, if we go back and look at our equation, we want to know where is sine theta negative 0.45. So we're going to say y equals negative 0.45. And if we zoom in on that graph, we're going to see that those two equations intersect at two places. So our two answers should be 3.61 rounded and 5.82 rounded. And why is my other one 5.81? Let me go back and recalculate that. 2 pi minus 0.47. 5.81. So there's a nearest tenth round off error, it looks like. Yeah, and that must be just round off error. So those are how you get your two answers with the Casio, with the unit circle, and verified with DESMOS. Okay, I hope that was helpful. If you have any questions or comments, feel free to leave them in the comments below. And thanks for watching.